Hello everyone, once again this is Sir O, your teacher in this session. So if you're new to my classroom, I will really appreciate if you can click the red button below this video, the subscribe button, and please consider clicking that notification bell for you to be updated with my next session or notified with my next tutorial. Our session today is actually topics taken from the grade 10 lessons. So without further ado, let us now start our session. So today you are going to know on how to evaluate arithmetic sequence. We will also include in this session illustrating actually the arithmetic sequence, and we will find the general or the end term of a sequence, and we will also consider arithmetic mean. Now to start, let us consider the sequence 2, 5, 8, 11, and so on and so forth. So this is actually an infinite sequence. Now if you're going to look at the sequence itself, if we subtract the second term by the first term, the difference is what we call as the common difference. That in this tutorial, we will make use of the symbol small letter d, which means common difference. So the difference between the second term and the first term is actually 3. And if we subtract the third term by the second term, the difference is still 3. And if we are going to subtract the fourth term by the third term, the common difference is still 3. So this 3 here, which is common to all of them, is what we call as the common difference. Now since the common difference, of course they are the same, that becomes an arithmetic sequence. So meaning to say, this sequence is what we call as an arithmetic sequence because the common difference or the difference among the terms in the sequence is the same. Now, this time, since this is an arithmetic sequence, let us now derive the formula or the general formula or the end term formula of the arithmetic sequence. So let us start. Of course, when we say a sub 1, that is referring to the first term of the sequence. In this example, the first term is 2. And of course, the first term is always equal to the first term, right? By the reflexive property. Now, if we are going to look at the second term, which is 5, that would be our second term. Now, the second term is actually your first term, which is 2 or a sub 1. We just added the common difference, which is 3. That is why we obtain our a sub 2 or the second term. So let us go to the third term, which is the a sub 3. If you notice, a sub 3 actually is just the second term, which is 5, a sub 2, added by the common difference, that would be our third term. But a sub 2 is just equal to a sub 1 plus d. Diba? A sub 2 is just equal to a sub 1 plus d. Here, you look at a sub 2 is equal to a sub 1 plus d. Plus d. So there are two common difference now. So that becomes the first term, adding the two common difference d plus d is equal to 2d. Now let's go to the fourth term. The fourth term is actually 8, which is the third term, added by the common difference. That is why we obtain 11, which is our fourth term. But a sub 3 is equal to a sub 1 plus 2d, isn't it? You look at here. A sub 3 is just equal to a sub 1 plus 2d. So adding d, so there are now 3 common difference. That is why it is equal to a sub 1 plus 3d. Now let's go to the fifth term. Of course, the fifth term is the fourth term plus the common difference. That would be our fifth term. But a sub 4, which is the fourth term, is just equivalent to a sub 1 plus 3d. There are now 4 common difference, therefore that is a sub 1 plus 4d. So therefore a sub 5 is just equivalent to a sub 1 plus 4d. Now you look at the sequence in the derivation of our general formula for arithmetic sequence. Did you observe patterns? Yes, no? If you're going to look at a sub 3, guys, if we are looking for the third term, that is actually equal to a sub 1 plus 2d. The third term subtracted by 1, if you notice 3 subtracted by 1, that is 2. Now in a sub 4, that is a sub 1, 4 minus 1 is 3. That is why a sub 1 plus 3d. Now you look at a sub 5. So a sub 5, a sub 1 plus 5 minus 1 is 4. So there is actually a pattern. So every time the number of term increases, subtract it by 1. That is now our new formula, isn't it? Now if you notice, let us base our last, shall we say, the a sub 5 as equivalent to a sub 1 plus 4d. If you notice, if we are looking for the n term, that is equivalent to a sub 1 plus, if you notice, we are looking for the n term. So a5, 5 minus 4. So therefore, n minus 1 multiplied by d. This one is actually what we call as arithmetic sequence. A sequence is an arithmetic sequence if the difference between any two consecutive terms. So when we say consecutive, in Filipino, that is sunod-sunod. Consecutive term is always the same. And this difference that we are referring to is what we call as the common difference. That is why the general formula of arithmetic sequence is a sub n is equal to a sub 1 plus open parenthesis n minus 1 close parenthesis multiplied by d, where a sub 1 is our first term, a sub n is our last term, and n is the number of terms, and d is our common difference. Let us now consider an example. Example number 1, given the sequence negative 3, 3, 9, 15, 21, and so on and so forth, find the 64th term. Now, for us to solve this, of course, it's very important that we are going to identify the given. Now, based on our sequence, and if you notice, if we subtract 9 by 3, that is also 6. If we subtract 15 by 9, that is also 6. And 21 minus 15, that is why our common difference is still 6. Now, you are asked, or we are asked to find the 64th term. So, actually, you can add the common difference 6 to 21 and so on until you reach 64th term by adding 6 to each term. But that would be a very inefficient method for us to do it. We did actually derive already the formula, so we will make use of it. So we have actually the common difference, and our first term based on our sequence is of course negative 3. Substituting the values to our formula, of course our n is 64 because we are looking for the 64th term. So meaning to say there are 64 terms all in this sequence. Our a sub 1 is of course negative 3, and our number of terms is 64 minus 1, and our common difference is 6. Simplifying first what is inside the parentheses, we have 63 because 64 minus 1 is 63 multiplied by 6. So next, we will multiply first 63 and 6. That is, a sub 64 is equal to negative 3 plus 378. Now, since this 2 is actually unlike sign, so what we are going to do is subtract them. So we have a sub 64 is equal to 375. So therefore, we are asked to find the 64th term. So therefore, the 64th term is 375. If you have some questions, you may write your question in the comment section. I will be happy to answer them. Example number 2. What is the 25th term in the sequence 6, 4, 2, 0, negative 2, and so on and so forth? Now, if you are going to subtract the second term by the first term, we will obtain our common difference. So we have common difference is negative 2 because 4 minus 6, that is unlike sign, so we subtract them. That is why that gives you negative 2. 2 minus 4 is still negative 2. So therefore, our common difference is negative 2. So our first term is of course 6. And applying our general formula for arithmetic sequence and applying what are the given to our general formula. So a sub n, because we are looking for the 25 terms, so that is a sub 25. Our a sub 1 is of course 6. Our number of terms is 25 because there are 25 terms all in this sequence, because you are asked the 25th term in the sequence. So what we are going to do here, of course, we subtract first 25 minus 1. We have a sub 25 is equal to 6 plus 24 times negative 2. So we will multiply first 24 by negative 2. That would give us 6 minus 48 because positive 24 times negative 2 is negative 48. 6 minus 48 are unlike signs, so we subtract them. So we have a sub 25 is equal to negative 42. In other words, therefore, our 25th term is negative 42. Example number 3. Now, if you are going to analyze the problem, the first term is not given. And we cannot solve immediately the common difference because we are not given the complete sequence. What we only knew is the third term and the 8th term of the sequence. So to solve this problem, actually there are so many approaches, methods, strategies for us to solve this problem. So in this session, what we are going to do, I'll be presenting to you one of the many methods in solving this problem. So based from the problem, the 8th term is 62. So that would give us an idea that in this problem, there are 8 terms all in this sequence. So the given are, the third term is of course 27, and our 8th term is 62, and we are asked for the 5th term, which is a sub 5. Now, based on the given, we cannot actually make use of the formula of the arithmetic sequence because there is no first term, and we cannot solve also the common difference. So what we are going to do in this problem is that we will assign a sub 3, which is 27, to be our first term. So if this will be our first term, that would follow that our 8th term, which is 62, is now assigned as the 6th term. Since the sixth term is given, which is 62, and our first term is 27, therefore we can now solve for the common difference. Because a sub 6 is equal to a sub 1, which is 27, plus we have 5d. Why? Because 6, we subtract this by 1, that is why 5. So substituting the given, we have a sub 6 is 62, and our first term is 27, plus 5d, and we transpose 27, so we have 62 minus 27 because positive becomes negative. Simplifying further, 62 minus 27 is 35. Dividing both sides by 5, our common difference is 7. So we can now solve for our a sub 3. So in other words, if we can solve a sub 3, that is also our a sub 5. So looking for a sub 3, that is equal to a sub 1 plus 2d, because 3, diba? 3 minus 1, that is 2, times the common difference. So a sub 3 is equal to a sub 1 is 27, plus 2, and our common difference is 7. Simplifying this further, we have a sub 3 equals 27 plus 14, because 2 times 7 is 14, and 27 plus 14 is 41. Our a sub 3 is 41. But since our a sub 3 is our a sub 5, therefore, our a sub 5 is 41. That will answer the question, what is the fifth term of the arithmetic sequence? Example number 4. What is the arithmetic mean between 19 and 35? So in this problem, we are asked to solve the arithmetic mean. So when we say arithmetic mean, the other term for this is the average. So when we are looking for the average, given two terms here, so we are looking for what is the term in between 19 and 35. So we know that there are 3 terms here because we are only looking for the term in between 19 and 35. So we have a sub 3, because there are 3 terms, a sub 1 plus 2d. Substituting it, we have a sub 3 is 35, on our first term is 19, plus 2d, so we can now solve for the common difference. Transposing 19 to the other side, that becomes 35 minus 19 is 16, dividing both sides by 2, the common difference is 8. So we are looking for what is the term in between 19 and 35, so therefore that would be the second term. So a sub 2 is equal to a sub 1 plus d. Substituting a sub 1, which is 19, and the common difference, which is 8, that is 19 plus 8. Our a sub 2 is 27. Now actually, I will be presenting to you another solution. We got already the value, which is a sub 2 is equal to 27. So I'll present another solution. The second solution is that we are looking for the number or the term in between 19 and 35. So therefore, there are 3 terms. The first term is 19 and the last term or the third term is 35. So we are looking for the term that is in between 19 and 35. So what you're going to do is we will just add the first term and the third term, which is 19 plus 35, is equal to 54. What we are going to do next is we just divide 54 by 2. That is equal to 27. So we arrive with the same answer. So it's up to you which solution that you are going to use for us to solve the arithmetic mean between 19 and 35. So if you are just given 2 terms and we are asked only one arithmetic mean, you can actually make use of the second solution if you like. Example number 3. So in this example, we are asked to find 3 arithmetic means between 7 and 43. So 3 plus 2 terms, that would be 5 terms. So the difference between example 4 and example 5 is that in example number 4, you are only asked 1 arithmetic mean. But in example number 5, there are 3 arithmetic means that we are going to solve. So for us to solve this, of course, there are 5 terms all in all. So our first term is 7 and our fifth term is 43. So therefore, our fifth term a sub 5 is equal to a sub 1 plus 4d, because we will subtract 5 by 1, so that is why 4. Substituting the value, our fifth term is 43 and our a sub 1 is 7. We are now ready to solve for the common difference. Transpose positive 7, that gives us 4d equals 36, because 43 minus 7 is 36. Dividing both sides by 4, that is, the common difference is 9. So what we are going to do is we will just add 9 to the first term. 7 plus 9 is 16, and 16 plus 9 is 25, and 25 plus 9 is of course 34. So these 3 terms here in between 7 and 43 is actually our arithmetic mean. So that would be our last example for this session. So don't forget to give a like to this video, and please do share this for others. And please do not forget, I would really appreciate if you can subscribe to my channel, and of course click that notification bell for you to be updated or notified with my next session. Thank you so much.